Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Ikhsan Joelyanda and my student number is 018. Today, we group 8 would like to explain to you what is word sense. Sense or word sense is a discrete representation of one aspect of meaning of a word. In dictionary or thesauruses, there are textual definition for each sense called glosses. For example, here are glosses for two meanings of the word bank. 1. Bank is a financial institution that accepts deposits and channels the money into lending activities. 2. Bank is a sloping land, especially the slope beside a body of water. For another example, there are the word mouse. 1. Mouse is a small rodent with pointy snout, small ears, elongated body, and a slender tail. 2. Mouse is a mobile manual device that controls the movement of cursor and the selection of function on a computer display. To put it simply, word sense is a set of meaning of a word in a sentence and its correlation with another word to make a preferable meaning. Because each sentence needs to convey a message, the meaning of the same word in those sentences can be altered to suit the message. This also correlates with the relation between sense, which will be explained by my friend.
Hello, my name is NADIA LIANDRI. My last student number is 014. Here, I want to explain about relations between sense. In relations between sense, we got some of point. It is synonymy, antonymy, taxonomic relations, meronymy, and structured polysemy. First, synonymy. What is synonymy? Synonymy is a relationship between senses rather than words. For words big and large, these may seem to be synonyms in the following sentences, since we could swap big and large in either sentence and retain the same meaning. For example, how big is that plane? Would I be flying on a large or small plane? 2. Antonymy. Whereas synonyms are words with similar meanings, antonyms are words with an opposite meaning like long, short, dark, light. 3. Taxonomic relation. In taxonomic relation, we have 2 points to explain. It is hyponym and hypernym. Hyponym is another word or sense if the first is more specific, denoting a subclass of the other. For example, car is a hyponym of vehicle, dog is a hyponym of animal. Hypernym. Hypernym that the class denoted by the subordinate extensionally includes the class denoted by the hyponym. For example, vehicle is a hypernym of car. Animal is a hypernym of dog. 4. Meronymy. Meronymy is the part-whole relation. For example, a wheel is part of a car. We say that wheel is a meronymy of car and car is halonym of wheel. 5. Structure polysemy. In structure polysemy has a subtype of polysemy relation is called metonymy. Metonymy is the use of one aspect of a concept to refer to other aspects of the entity or the entity itself. For example, when we use the phrase the White House to refer to administration whose office is in the White House. I think that's all for my explanation. The next will be explanation by my friend.
Hello everyone, my name is FATMA SARI. My roster number is 016. We are going to talk about WordNet, a database of lexical relation. In this database lexical relation, we have 4 parts. First, we have WordNet, and then we have gloss, and then synset, and supersense. First, we are going to talk about WordNet. What is WordNet? WordNet is the overarching lexical database that contains a large collection of words organized into synset, which represent specific concepts. And then we are going to talk about gloss. What is a gloss? A gloss is a brief description or definition of a word's meaning. Each synset in WordNet has a gloss that provides a concise explanation of concept the synset represents. And then we have synset. What is a synset? Synset is a set of synonyms that represent a specific concept or meaning of a word. In WordNet, words are synonymous and share the same sense or grouped together into synset. And then we have supersense. What is supersense? Supersense are broader categories or semantic classes that group relate synset together based on their common meaning. They provide a higher level classification of concept. Here, I will give you an example. Consider the word cat in WordNet. In WordNet, the overall lexical database and synset. In WordNet, cat may have multiple synsets. One synset could represent feline mammal, and other could represent domestic cat. For the gloss, for the feline mammal synset, the gloss might be any several large cats typically able to roar and living in the wild. For the domestic cat synset, the gloss could be a small domesticated carnivorous mammal. Supersense. Supersense classifies synsets into broader semantic categories. For example, the supersense for both feline mammal and domestic cat could be animal. Okay, in this example, you have the word cat represented in WordNet with different synsets. Each having a gloss and concept can be categorized under a supersense like animal to show the broader semantic class. Okay, next we are going to talk about sense relation in WordNet. WordNet represents the sense relation between words through various semantic relations. Some of the most common sense relations in WordNet include hyponymy or hypernymy, synonymy, antonymy, meronymy or holonymy, troponymy, entitlement, attribute, similarity. First, hypernymy or hyponymy. This relation represents the is-a relationship between words. A hyponym is a more specific term that is subtype of a broader category. The hyponym, for the example, rose, is a hyponym of flower, as a rose is a type of flower. Second one is synonymy. Synonymy represent words with similar meaning. Synonyms are words that can be used interchangeably in a specific context. For example, happy and joyful are synonyms. Third, we have antonymy. Antonymy represent words with opposite meaning. Antonyms are the words that convey contrasting idea. For example, hot and cold are antonym. And then, meronymy or holonymy. Meronymy represents part-whole relationship where a word denotes a part of another word. Holonymy is the reverse, indicating that a word encompasses other parts. For the example, wheel is a meronym of car, and car is holonym of wheel. 5. We have troponymy. Troponymy represents a specific manner or method of doing something. For example, crawl is troponym of move because it specifies a particular way of moving. Six, we have entitlement. This relation indicates that the truth of one word's meaning implies the truth of another word meanings. For example, if someone eats something, it entails that they consume it. Seven, we have attribute. This relation connects a noun with an adjective that represents one of its inherent attributes. For example, color is an attribute of apple, connecting red with apple. And then 8, similarity. This relation represents words that are similar in some aspect, but might not be true synonyms. For example, cat and dog are similar because they are both domestic animals, but they are not synonyms. Okay, that's all for me. Let's go on to the next speaker.
Hello, my name is KAYLA AZ-ZAHRA. My student number is 060-111-822-227-015. In this video, I would like to explain about word sense disambiguation, or WSD. First, let's talk about definition of word sense disambiguation. Word sense disambiguation, or WSD, is a subtask of natural language processing that deals with the problem of identifying the correct sense of a word in context. Many words in natural language have multiple meanings, and WSD aims to disambiguate the correct sense of a word in particular context. Next, we are going to talk about types of WSD. However, before that, we have to learn two words that will often appear in this discourse. First, lemma. A lemma is an entry in the dictionary. A lemma can have several meanings. For example, the word bank has several meanings. The first sense is financial institution, and the second sense is riverbank. Second, sense. Sense is a discrete representation of the meaning of the word. This term is commonly used to express the meaning of the word. Now, we are going to talk about types of word sense disambiguation, or WSD. A. Lexical sample test. In some situations, we just need to disambiguate a small number of words. In such lexical sample task, we have a small preselected set of target words and then inventory of senses for each word from some lexicon. Since the set of words and the set of senses are small, simple supervised classification approaches work very well. B. All-word task. More commonly, however, we have a harder problem in which we have to disambiguate all the words in some text. In this all-word task, the system is given an entire text and a lexicon with an inventory of senses for each entry, and we have to disambiguate every word in the text, or sometimes just every content word. All words task is similar to part of speech tagging, except with a much larger set of text, since each lemma has its own set. The consequence of this larger set of text is data sparseness. This is an illustration of all-word WSD tasks. As you can see, we have a sentence: an electric guitar and bass player stand off to one side. All words in the open class will be labeled, not including the prefix like and. Every open class word will be given sense. So according to the thesaurus, electric has three senses. The first sense is using electricity, the second sense is dance, the third sense is thrilling. Guitars only have one sense. Bass has 7 senses. Players have 3 Senses. Stands have 10 senses, and sights have 11 senses. C. Semantic concordance. Semantic concordance, word sense disambiguations (WSD), is a method that uses a large database or corpus to determine the meaning of a word by analyzing its usage and context across various examples in the corpus, helping to disambiguate word senses based on real-world context and co-occurrence patterns. Next, we are going to talk about methods for solving word sense disambiguation. First, supervised machine learning requires a set of sense tags, a training body which contains words already labeled with appropriate sense, features extracted from the training body, and a classifier, a naive Bayes. This method uses probabilistic models like naive Bayes to calculate the probability of a word belonging to a particular sense given its context. It relies on label training data to estimate these probabilities. Support vector machines, or SVM. SVMs can be used for WSD by training a classifier that maps the context of a word to a specific sense. Features derived from the context, such as back of words or word embeddings, are used as input to the SVM. Second, thesaurus or dictionary. Word sense disambiguation (WSD) using a thesaurus is an approach that relies on thesaurus or similar lexical resources to disambiguate word senses. Thesaurus provide information about synonyms and related words which can be used to infer the meaning of a word in context. Here are several methods and techniques for solving WSD using thesaurus. A. Less algorithm. B. Extended less algorithm. C. Thesaurus-based features. D. Word sense discrimination. E. Word history. Third, semi-supervised machine learning. Bootstrapping. A seed set of labeled examples is used to train a classifier, and then this classifier is used to label more examples. The process iterates, expanding the labeled dataset and improving the model's accuracy over time. Most frequent sense. Most frequent sense, word sense disambiguation (WSD) is an approach that assigns the most commonly occurring sense of a word in a given context as the correct sense. This method assumes that the most frequent sense is the one that applies in the given context, but it may not be accurate in cases where word senses vary significantly in different contexts. One sense per discourse. One sense per discourse, OSD, is a word sense disambiguation approach that selects a single sense for an ambiguous word in a document and assumes that this sense remains consistent throughout the entire text, simplifying WSD by reducing the need for disambiguation for each occurrence of the word. It is useful in documents with relatively uniform context, but the sense of the ambiguous word doesn't change significantly. The last example of using WordNet. If we search the word bank on the WordNet website, the website will display many results related to the keywords we are looking for. I think that's all from me. Thank you. The next material will be explained by my friend.
Back to me. Now we move on to alternate WSD algorithms and tasks. There are 4 ways that you can use. First is feature-based word sense disambiguation. This is the extremely simple and function almost as well as contextual language model of algorithms. This algorithm uses a classifier to choose the sense for each input of word, like part of speech tags, collocation, which means the adjacent word of target words, and weighted average of embeddings. The second is less algorithm as WSD baseline. Less algorithms is the oldest and most powerful knowledge-based WSD method, and it's useful as baseline. For example, the word sense bank have overlap with context of deposits and mortgage, while sense bank 2 has 0. So sense bank 1 is chosen. The third is word in context evaluation. In this system, it is given two sentences, each with the same target word but in a different sentential context. The system must decide whether the target words are used in the same sense in the two sentences or in a different sense. And last is the Wikipedia as source of data training. When concept is mentioned in a Wikipedia article, the article text may contain an explicit link to the concept Wikipedia page, which is named by a unique identifier. You can clearly see here in the example the blue font underline word for definition has its own link. This link can be used as a sense of annotation. I think that's all from me. Thank you.
Hello, my name is NADIA ATIKA DAMAYANTI and my last student number is 057. I would like to tell about the thesaurus and word sense induction. The thesaurus can be used to improve word embeddings and word sense induction in several ways. One approach is to incorporate thesaurus information during the training of word embeddings. This can be done by modifying the training process to include synonymy, antonymy, or other relations from the thesaurus. By incorporating this information, the embeddings can be adjusted to better capture the relationships between words, including their different senses. Another method is retrofitting and counterfitting, which is applied to static words embeddings. After the embeddings have been trained, a second mapping is learned based on the thesaurus. This mapping adjusts the embeddings of words so that synonyms are pushed closer together and antonyms are pushed further apart. This helps to improve the discrimination between different senses of a word. And here's the example before counterfeiting and after counterfeiting. We use word is, expensive, and British as example. And for the last one is word sense induction. It's a computational technique in natural language processing or NLP aimed at identifying the different meanings or senses of a word based on its usage in context. Since many words have multiple meanings, determining the correct sense of a word in a particular sentence is crucial for accurate language understanding in NLP application. WSI algorithms analyze large corpora of text to identify patterns and contexts in which a word appears. By detecting similarities in how the word is used across different sentences, documents, or contexts, these algorithms group instances of the word into clusters, with each cluster representing a specific sense or meaning of the word. The goal of WSI is to enable machines to disambiguate words in context, allowing for more precise and contextually accurate natural language processing tasks. This technique is valuable in various applications including machine translation, information retrieval, text summarization, and sentiment analysis, where understanding the nuanced meaning of words is essential for meaningful analysis and interpretation of textual data. Okay, now let's consider the word mouse as an example. Depending on the context, it can refer to different things. For the first one is computer device. She used the mouse to navigate the computer interface. And 2. Small mammal. The cat chased the mouse around the garden. A word sense induction algorithm would analyze a large corpus of text containing sentences like this. By identifying patterns in words surrounding mouse in these sentences, the algorithm would cluster similar usage in the word into distinct senses. Sense 1. Computer device. She clicked the mouse to open the application. The mouse pointer moves smoothly across the screen. Sense 2. Small mammal. The mouse scurried away when it saw the cat. Farmers use traps to catch field mice. Okay, I think that's all from Group 8. Thank you very much.